That's weird, right?
It's an inference problem, to be honest, like a software problem. Like oftentimes, the image you run, NVIDIA will release an image, for instance, and if we will upstream the changes from their latest RTLM image into our stack, we'll find that it fixes it. Or oftentimes, this will only happen in an inference engine that you're using, like SGLang. But if you were to switch to VLM, that isn't the case. So it seems to be like an extremely non-deterministic kind of software issue and not really a model issue. It's not like a weights problem. Like we'll say it's a problem with the quant. We did PTQ wrong, right? But that doesn't make sense because the same exact weights used with a different inference engine does not repeat the problem. And sometimes it's the kernels that are being used in the backend have like these very subtle, sometimes race conditions where if you were to use this model hosted on one cluster, you will never get this problem.
Oh my God.
But if you host it on a different cluster, you will. And the reason is the KV cache transfer from a node to node in that one cluster is using a slower interconnect than the node to node in another cluster. So that exposes the race, whereas in another cluster it doesn't. So then you end up just like, okay, this model is not going to be hosted on this cluster. We're going to host it on, another cluster because that cluster exposes that problem. But then it ends up with like, okay, is it the software, is it the model weights, or is it the hardware?
There was a thing about this with temperature zero still not being deterministic, right? Mostly because of hardware. Even at temperature zero, same model, you won't always get the same output.
But I'm surprised by the race condition one because I thought PyTorch was a graph that like guarantees that you at least, execute things in the right order.
Well, true. Like I guess I'm not